Hi there and welcome to this video for Senior Physics on Motion. In this video, we're going to be looking at distance and displacement and basically working out the differences between the two. We're going to look at how we can actually work out our displacement using Pythagoras and trigonometry, and then we're going to also be looking at how we can use or interpret displacement time graphs. Okay, so let's start off right at the beginning. We know that distance basically is how far an object goes. However, displacement basically takes into account the distance you've travelled plus the direction. Now, in order to show direction, especially when we're looking on a single plane, we use the mathematical notation of positive meaning one direction and negative being the opposite. And you'll find that throughout your physics that this positive and negative vector is always utilised. Now, this becomes very apparent when you're actually trying to do some calculations. So we'll do a quick simple calculation so that you sort of understand where we're going with. So look at this scenario here. We're starting off at home. See the house there on your left. We move 15 meters in to the right, and then we come back 5 meters to the left. Now let's say we use 15 let's say we make moving to the right positive, and then obviously moving the opposite direction negative, so moving to the left negative. So we've gone positive 15 meters and then negative 5 meters. Okay, so the distance, what we're going to be able to calculate is the distance traveled, which basically is going to be combining those two distances together. Okay, because how far did I travel? I went 15 meters and then I did another 5 meters. So that's the total distance. But my displacement is going to be how far do I end up from home? So I went 15 positive and then I came back 5 meters. So in the end, I ended up 10 meters away from home. Now, because it's 10 meters to the right, it's a positive. If I wanted to show that I was going the opposite direction, then obviously it would be negative. So in this case, I've got 15 meters, positive 15 meters, because I'm going to the right, and then I come back negative 15 meters, as negative 5 meters, so 15 minus 5 gives me 10. So now, as you can see, there's a direct definition or difference between distance and displacement. Displacement basically is going to be your final distance from home, whereas the distance travelled is how far I've gone. Now, this is fine when we're working on a planar, a single plane, but it often helps to draw a scale diagram, especially when we're looking at two planes. And in this case, we have to use Pythagoras and trigonometry. So let's take the scenario here. I'm starting off at home, and I'm going to use the compass heading there, but I'm going to go 7 kilometers east, and then I'm going to go 5 kilometers north. Now, because they're not on the same plane, the result is I cannot just add them together. I can add the two vectors together, and we'll cross that bridge later on in the course. So what I now need to do is to say, well, how far, what's my displacement when I end up? So these are the sorts of questions that you're going to be likely to ask. And in order to do this, we have to draw a diagram. As you can see here, I want to work out where do I eventually end up. Well, I don't end up either left or right. I'm at an angle away from left and right. So let's see how we work that through. So first off, I can work out my distance. I can then work out my displacement distance. I can then work out my displacement direction, and then I can work out my overall displacement. Now, the total distance that I walked, if I followed those two vectors, would be 7 plus 5, which is 12 kilometers. That's how far I went. How far do I end up from home would be my displacement distance. Okay, that's how far that green line happens to be. Where do I end up, okay, from home once I've done that journey? Because it might not be feasible to follow that green line. I may have to take the path shown by the purple and blue line. So in order to do this, we've got a right angle triangle. So I use Pythagoras. So Pythagoras basically is a squared equals b squared plus c squared. So I've got my two vertical and horizontal components. So it's the square root of the squares of those two lines. So it's the square root of 7 squared plus 5 squared, which gives me a total displacement distance of 8.6 kilometers. That's the green line. Now, because its displacement is a vector, I've then got to work out the direction. The direction will then be using trigonometry. Now, in this case, I want to find the angle where the house is. So I've got the opposite, which is the 5 kilometer, and the adjacent, which is the 7 kilometer, which means I use tan in trigonometry. And I divide the opposite by the adjacent. So it's tan to the negative 1, 5 over 7, which comes out at 39 degrees. Now because I'm going east and then moving north, the result is my bearing will be, I'm facing east, I then move 39 degrees in a northerly direction. So my overall displacement for that journey is 8.6 kilometers east, 39 degrees north. Okay, I hope that makes sense. Now another way that we can interpret displacement is using displacement time graphs. So in the displacement time graph, the key thing you've got to understand when you're looking at graphs is make sure you look at the axes. Especially when we're doing displacement, velocity time, acceleration time, you've got to continually keep looking at the axes because they're going to change. In this case, we've got displacement up the left-hand side and we've got time along the x-axis, and we've got a nice straight line. Now the gradient for a displacement time graph will give me the velocity. That's how steep the line is. Now the gradient can be calculated by the rise over the run. The rise over the run is basically the change in distance of the y-axis divided by the change of the x-axis, or delta s over delta t. Now those of you going on to Math C will be looking at calculus. Calculus basically looks at the change in y over the change in x in a very simplistic term. So you can incorporate some of your calculus into this rate of change which is occurring. Now obviously the steeper the graph, the greater the rate. So for a displacement time graph, the gradient is then going to be basically the velocity, which is the change in distance over the change in time. Now in this case we're looking at a displacement situation. So V equals delta S over delta T. Sometimes you'll see it as V equals D over T. Okay, so that gives us either a speed, or if we're dealing with a vector, it's going to be a velocity. Now in this case, because we've got a straight line, our velocity can be stated as being constant. It doesn't change. We're going at the same speed because we've got the same gradient all the time. Okay, so we've got two graphs that you can see here, which are basically work that we did in year 10. If you look at the top graph, basically what you can see is you've got a horizontal orange line. That horizontal line means that the distance from home, the displacement from home, doesn't change as time continues. That basically means we're at rest. We are not moving. Our velocity is zero. So the displacement is not progressing as time is. In the second one, you can see that the gradient is continually changing. Now, what's happening here is that because the gradient's changing, the velocity's changing. Think back to our terms in our first video. A change in velocity is also termed acceleration, which means in this case we've got acceleration occurring. If it's a nice smooth curve, it'll mean we've got a constant acceleration which is occurring, because what's happening is our displacement from home is changing with time, but it's not at a constant rate. Okay, it's continually getting steeper and steeper. Our speed is continually getting faster and faster. Okay, well let's have a look at these two graphs. What I'd like you to do is pause the video now and try and determine what's happened in these two graphs when we'll run through the answers, and I've got another graph to look at on the other page. Okay, so pause the video now and try and work out what's happening in these graphs. Okay, welcome back. How did you get on? Well, let's look at the first graph. Now in the first graph I've got a straight line on distance time graph, so that means that the velocity is constant. Then I get a horizontal, which means we've stopped, and then we speed up again. So what this means is the object's moved away from the house at a constant speed, it's stopped, and then it's moved off again at the same speed later on. Did you get that right? If you did, then you've got a good idea as to how to deal with. Sorry about that, that was our bell. Now in the second graph, what we've got is the opposite. What this means here is the displacement, we've got a constant velocity, okay, but it's going the opposite direction. All this means is that on the displacement graph, it's getting closer to home. Then we stop for a bit, and then exactly the same, we're moving back to home as we go with time. Notice that in this case, where the velocity is not getting slower, it's still constant. The gradient's the same. Let's look at this final graph. Pause it now and see what you can work out. Okay, welcome back. So in this case, what we've got is we've got a constant velocity, so it's moving away from home. Then we stop for a bit, and then we've got a constant velocity where we're moving back to home, and then we're going on the opposite side of home, hence we're going into the negative section of the graph. So in this case, we've got our velocity in that last section is constant, but we go back to home, we get to home, and then we carry on at the same speed going straight past home. That's what that graph is showing. Okay, well, I hope you found that useful, and I look forward to you joining me again for some more on motion and our senior physics. I look forward to joining you then. Thanks for watching.